Good afternoon, everyone, and thank you so much for joining me for another Kivu Coffee Break. My name is Nick Steinman, and joining me today is Sarah Grace Houston from Kivu's Incident Response Team located in our New York office. As everyone knows, the computer industry moves at a wicked fast pace. The industry has created and recreated everyday items from devices in our kitchen to devices in our pockets. So, in essence, the computing industry can effectively say that they have reinvented the wheel multiple times over. So, where are we on this digital journey? And furthermore, where are we headed? Sarah Grace, with that said, are you able to provide our viewers with some information on the early days of computing?
Sure can. Humans have been computing in some form or another since the Sumerians in 2000 BC, but not like we see computing today, obviously. The first step on the way to computers as we know them was in 1801 with Joseph Marie Jacquard's loom, one of the first recognized automated machines. It used wooden punch cards to automatically weave fabric patterns. If that structure sounds familiar, it should. Punch cards with specific commands were the cornerstone of early computers. Beginning in 1822, British mathematician Charles Babbage invented the difference engine, which performed simple calculations. Further, he and Ada Lovelace laid the foundation of the modern computer by putting the mill, or CPU, as we know it today, in store, or memory, with their analytical engine in 1837, but their idea remained conceptual. In 1890, however, Ramon Hollerith combined the ideas from Babbage, Lovelace, and Jacquard to successfully create a punch card system to calculate the 1880 census. Then in the midst of World War II, Alan Turing came along to help crack Germany's Enigma machine and started to develop the ideas of a universal or Turing machine, which was a simple machine capable of computing any possible computation and completing defined tasks set up by an algorithm. If you saw one of my all-time favorite movies, 2014's The Imitation Game, you got to see how through theorizing, Turing created the modern-day computer.
You know, it's really interesting to think that if Babbage and Lovelace's concept did come to fruition, we would be referring to the CPU as a mill. However, of course, nothing gets done without proof of concept. So, what else can you say about the history of computing?
There's a lot to say, so it's a bit of a speed round time. In 1937, John Atanasoff developed a technique for using computers in a vacuum. Think of this as the medieval circuit board. In 1939, complex number calculator by Bell Laboratories becomes the first example of remote access computing. In 1941, Atanasoff and Clifford Berry designed a computer that can solve multiple equations simultaneously. It was the first computer known to store information in a main memory. In 1946, work on an unveiling of ENIAC happened, the first electronic general-purpose computer and first full-functioning digital computer to be built in the US. The original one was the German Colossus in 1944. In 1947, Bell Laboratories invents the transistor, aka an electric switch with no need for the use of a vacuum. Big game changer. In 1948, the first program to run on a computer was a small-scale experimental machine, aka the Manchester Baby. In 1953, Grace Hopper, known as the First Lady of Software, develops the first computer language known as COBOL. In 1958, Jack Kilby and Robert Noyce created an integrated circuit known as a computer chip, another game changer. In 1964, Douglas Engelbart displays a prototype for what we recognize today as the first modern computer, with a mouse and a graphical user interface, or GUI, marking the change in computers going from scientific tools to something accessible to the public. And throughout the 1960s, NASA was still using computers in the traditional sense of the term. Men and women who hand computed equations and manually created the algorithms that got a man on the moon. If you've seen the 2016 hit film Hidden Figures, you might remember the brilliant Mary Jackson, Katherine Johnson, and Dorothy Vaughan and their extraordinary pioneering work in algorithms, which we still use today in computers.
Wow, and you know, fun fact about Katherine Johnson, she actually wrote the handbook that on calculating machines for NASA.
What an icon, one of my heroes. Now let's change gears from the computer side of things to the development of the internet. In 1966, Advanced Research Projects Agency in the U.S. Department of Defense created the first wide-area packet switching network, otherwise known as the early internet. In 1973, Robert Metcalfe develops Ethernet, enabling the connection of multiple computers and other hardware. In 1976, Apple Computers is started with the rollout of the Apple I, the first computer with a single circuit board, making those connections even faster. In 1990, Tim Berners-Lee invents the World Wide Web by taking CERN's concept of hypertext and connecting with transmission control protocol and domain name system, as well as creating the first web browser.
And you know, random fact about ARPANET. The Advanced Research Project Agency was created in 1958 by President Eisenhower as a response to the Soviets successfully launching Sputnik in 1957. But I think what's most amazing to me is that out of all this research and development in the course of 219 years has spawned creation of things like smartwatches, Wi-Fi, glucose monitors, internet-connected light bulbs, and even ride-hailing apps. I mean, you can't even microwave popcorn without a computer. After all, a digital timer is in fact a computer.
I know, and without all that we've learned from these tinkers and inventors, we would not be where we are today. And that said, I'm extremely excited for what's to come in the computing world. And Nick, we're 19 years removed from 2001. Where is my HAL 9000? I want one.
Well, let's be sure a human physically touches the monolith instead of a smart glove. But I am interested to see what's in store for quantum computing. Of course, conceptualized in the 1980s, we've seen tremendous public and private investment into quantum computing within the last few years, as it is turning into a modern-day space race. As you know, computing languages like Python, Java, Ruby, these behind all those, they still work in zeros and ones. However, a quantum circuit model is based off of the quantum bit, or a qubit. These qubits can either be 0, 1, or a superposition of 0 or 1. And while the result of quantum computational efforts will always remain in 0 or 1, a quantum computer will reach the answer significantly faster.
Nice. And dollars and cents aside, when do you think the average consumer will be able to buy one of these quantum computers? Just asking for a friend.
Well, unlikely, because it's important to remember that we still have a mountain of research and development that we need to complete. After all, researchers are still trying to get qubits to behave in the way that we want them to. However, these types of computers are going to be used more for research and security. So quantum computers are seriously fast, but they're going to be used more for things like climate and weather modeling, stock market analysis, and security strengthening. Furthermore, in regards to security strengthening, this is why these quantum computers are a modern-day space race. A quantum computer will be able to easily crack all current encryption methods, and furthermore, they'll be able to write stronger algorithms that contain tremendous complexity.
Wow, that is both exciting and terrifying. I can't wait. Well, thank you all for joining us for another Kivu Coffee Break. As always, please be sure to leave a comment below if you have any questions regarding the history or future of computers. And as always, please feel free to reach out to the Kivu team if you have any questions or any security concerns. See you all next week.